my name is Bethany Fowler. I am a third-year graduate student working with Heidi, Sosik, and Mike Neubert. I came to Woods Hole with a background in mathematics and a love of ecology. I was really eager to study ecological theory and how that field, how modeling in particular, can help us understand really complicated real-world ecosystems. The Northeast U.S. shelf is certainly a complex ecosystem, but one of the great things about working with the LTER is being able to work with diverse scientists who are oceanographers and engineers and experimentalists, and breaking that complex system into understandable components. I love working with the schoolyard portion of the LTER. The Data Jam project is so fun, and creating the data sets and presenting them in a way that's clear and approachable for students is a really fun challenge, and I think it's really rewarding to see the students interact with that data and experience some of the excitement and uncertainty of scientific exploration. My own research focuses on the smallest class of phytoplankton, the pico-phytoplankton. Because size is such an important trait in marine ecology, this group is sometimes lumped together or assumed to be doing the same things at the same time. But my question was whether that was true on the Northeast U.S. shelf, or whether the taxonomic diversity that we see is corresponding to functional diversity. So there are eukaryotic and prokaryotic pico-phytoplankton, and they can be distinguished based on their fluorescent signature. So we can count them and identify them with an autonomous flow cytometer. But what we can't see from that is how quickly they're reproducing or how quickly they're growing. Because there's such rapid turnover in the Northeast U.S. shelf, the phytoplankton are growing and being eaten so quickly that changes in biomass might not correspond to changes in growth rate. So in order to figure out how fast they're growing, we really need to integrate observations from this instrument with population models. And if we do that, we can quantify division rates or estimate division rates for the different groups of pico-phytoplankton. And what we found is that the eukaryotes are dividing much more rapidly than the prokaryotes, but they stay at lower concentrations. So their biomass is lower, and there's a lot more turnover happening in the eukaryotic component. So this raises all sorts of questions as to why that is, whether the group is being preferentially eaten, and if so, by who or what. And so this is where it's really exciting to work with the LTER team, who is equipped with the tools to look further up the food chain and paint a more complete picture of this system.